Yeah,
I'm tired.
I hear you.
Says we're live.
Yeah. Give it just a minute. I always like to make sure YouTube catches up because they're...
Good idea.
There we go. All right. Welcome everybody to another episode of our Workflow Wednesday podcast or video podcast.
Video
this
podcast,
week,
probably.
Yeah. This week we're joined by the one and only, the 3D printing nerd, Joel Telling. Yeah, this one's very exciting because this one's a little different because oftentimes we have you're a content creator, YouTube
True.
and things like that, but also you dabble your 3D printing stuff.
That's right.
Touches on workflows that I don't think we've really talked about yet. So I'm really excited for this one. The 3D.
I'm kind of excited, man.
So just in case somebody out there doesn't already know who you are, give us a little introduction, who you are, what you do, and all that good
Sure. Well, hello to everyone who might not know who I am. My name is Joel Telling. I host 3D Printing Nerd, a show on YouTube that educates and inspires all while having a really good time. I create family-friendly content, and I try to inspire anyone and everyone around the globe, no matter where you are, where you come from, to just make cool stuff and have fun while you do it.
Right on. Awesome. So, I guess right off the bat, and just in case anybody watching, please do, if you have any questions, go ahead and put them into the chat. We'll get to those as we possibly can.
For me.
And so please do. But so right off the bat, I'm really curious how, I'm going to be really basic, but how did you get into it? Where did the 3D printing come from? Like, where did you start?
Well, that's a super good question. So back in the day, my first printer was a FlashForge Creator Pro that my wife and kids got for me Christmas of 2014. Before that, I'd always just liked 3D printing, but it was like one of those things where I didn't have spare funds to just throw at a hobby, or spare funds to throw at another hobby sort of thing. But I watched a lot of Tom Sandlatterer, Tom's 3DP. He's the German YouTube person who's just, I mean, my friend as well. And then also Jerry, Barnacules Nerdgasm, you know that guy.
Right.
Who
he was pretty early on
stream to after our show today. So, shout out to Jerry. You gotta give him a hug when it's safe. So I watched those guys. They were talking about 3D printing and how cool it was. And it looked neat, right? I'm a giant nerd, so I like cool things like that. So my wife and kids got me the printer for Christmas 2014. And after that, I remember just diving deep, trying to do stuff. And eventually I was like, I'm learning how to do stuff. I think others should learn how to do it as well. And I had recording equipment, and I thought, let's just put it all together. And I know I'm a nerd and I like 3D printing. So 3D Printing Nerd was born. And that's literally where it came from.
That's awesome. So, I feel like we've come quite a long way. It's 6 years, I guess, since you really started, and probably closer to 10 since I suppose consumer level 3D printing has kind of become a thing. And it's cheaper than it's ever been to get it started. What they have, like, I think Prusa has like a $200 3D printer. You can just,
well, not exactly, but we can for FDM printers, or the kinds that melt plastic to deposit onto a build plate. $200 to $300 is going to get you a decent machine and some material to play with. As on the resin side of things, same price. You can, $300 is going to get you, a little bit of resin and a smaller machine that prints really well. There really hasn't been a better time to get into this hobby if this was something you were curious about.
For sure. And you were right. It was a resin printer I had pictured in my mind. It's fairly cheap. Yeah. I know it's like I think I had the wrong brand, but it's fairly cheap, real easy to get into resin.
Prusa makes the Prusa Mini or Mini Plus, which I believe is $399 US. The really less expensive ones that perform really well are from Creality. One of the most popular ones is the Ender 3 platform. You can get the Ender 3 V2, which is the Ender 3 platform with some upgrades installed by Creality, I think for $250, $260 US, something like that.
Oh yeah, okay. Wow. See, that's super cool. And well, that'll go off on a tangent. Never mind. I'm
There are
surprised.
so many tangents we'll be able to take from
Oh,
this, and so I think you're going to have to rein it in a little bit.
for sure, for sure. Because I'm shocked at the fidelity that we can get both in resin and
Mhm.
filament printing, like tiny millimeter, little bit, and it's super cool. But I'm curious. Say you wanted to create something from scratch. You have places like Thingiverse and things like that where you can find 3D models to print or slice and print and things.
Mhm.
But what's the process from idea to model? Like, how
Oh,
does
I see
that
what you're
work?
saying. I see what you're saying. So, it depends. That's a very personal process, but for
Okay.
most, typically you want to sketch something out first and give it some sort of dimension. Paper or whether it's on the computer and you're drawing something in Photoshop or GIMP or whatever.
Mhm.
Uh, but then you move to the digital side of things, and honestly, right now it's crazy. So if I don't know if you've heard of Tinkercad, but it's web based, just like the streaming platform we're on here, web based, but it's a
Right.
web based CAD engine that
Okay.
is very simple to use. It's based on simplicity. It's essentially you can dimension things and you're taking shapes and adding and subtracting them from themselves. I mean, if you have
Oh.
if you have a cube, you take a sphere and you smush it into the cube, and then you
Mhm.
subtract that sphere, it's going to leave a hole, right?
Oh, cool. Okay. Yeah.
Yeah. So imagine that,
Wow.
but on steroids. So that's kind of what that is. And it's web
Okay.
based, and it allows you to create really easily. There's
Nice.
also Autodesk Fusion 360, which is a really popular CAD program that allows you to go even further down the rabbit hole because it's more precise and it has more tools built for engineering specific tasks.
Okay. Right on. What do you use then for your personal?
I like Fusion 360 just
Mhm.
because it's what I started to learn in, and it's easy enough for me to do simple tasks. Tinkercad also works well, just because with Tinkercad, if you have a basic model like that you've downloaded from Thingiverse or My Manufacturer or whatever, it's easy enough to import into that if you want to change it. There's slightly extra steps that you have to take to do it in Fusion 360, and it's a little bit more complex. But
Okay.
I am 90% of the time Fusion 360 for anything that I need to create from scratch. And if I need to edit something, then typically it's Tinkercad.
Okay. Cool.
Yeah,
Right on.
typically.
Right on.
I know there's lots of other options that I'm not mentioning here, but again, tangents and rabbit holes.
Sure. Yeah, because there have been some mentions. Ben E. Brady on YouTube mentioned Design Spark Mechanical.
Sure.
Garth Asper mentioned Inventor.
Oh,
A
and
few of those.
Autodesk Inventor, Onshape, SolidWorks,
Oh,
Morphe
SolidWorks.
on the iPad, even
All
on in
right.
Windows, 3D Builder from Microsoft.
That's
Yeah,
pretty cool. So
it's
right on.
it's nuts.
That's awesome. Okay, we do have a first question again from
Oh yeah.
Garth Asper. He asks, if you would make a printer farm and you had unlimited money, what printer would you pick?
That is a fantastic question, but it needs a little bit more refinement because
Okay.
typically a printer farm is built to fulfill a specific need.
Oh,
For example, my buddy Luke at Out of Darts produces parts to make Nerf blasters, custom
oh,
Nerf blasters, Nerf carriages, flywheels, all that kind of stuff. He
that's
has
cool.
a print farm, I think, of 80 different Prusa 3D printers, just
Mhm.
because he went with what he knew and what had good support, and those seem to work for the height, the width, and the depth of all the parts that he needs to print fast and consistently. Some people, though, they might have to pivot their farm to printing longer objects. So maybe a belt printer solution is the way to go, or perhaps tall objects, and you need a bunch of industrial grade Ultimakers or raised 3D machines that are super, super tall, or
Hmm.
perhaps you're based in a country that it's harder to import certain things, and
Okay.
so the craft bot machines I know are sourced out of a different part of the world, and so sometimes they're easier to get if you're in
Oh,
the European side of things, or stacker machines over there. Really, sometimes people will say, I want to create a print farm because I want to print things for others. You want to
okay.
do commission-based printing. And so really just a general overall approach to this is a good example is actually my buddy Alan, who has Repcord. He goes by Pooch. And
Okay.
he has, I think it's 25 different Prusa i3 Mark III S 3D printers. And he's got some other machines just to do the projects that those might not be able to do. But for 99% of the load that he has to support, the size of the Prussias are acceptable. And so I like the question, but it's just it's not just I want to print farm so I can do this. It's, well, what need are you going to service? You know, what parts are you going to make, or who's your customer? So there's a lot more questions that really go into that. I do like the idea of having unlimited money, though, because then, you know, I would buy exactly what I need.
Sure.
I hope that makes sense.
I'll just for my own personal interest, let me expand and say, what if I wanted to print like, say, Dungeons and Dragons minis?
Okay.
On a massive scale, like bunches of them all at the same time. Something like how Hero Forge, I think, does something similar.
Sure. Or I know our buddies at Level 52, close to Puget. They're also doing the 3D printing minis as well. If you want to do that, you want a number of resin 3D printers that have high quality. But honestly, there's something called from the company Frozen called the Sonic Mini 4K.
Ooh.
So it's got a build plate that's just about that big, but it has a 4K screen on it. So you're getting the highest fidelity possible on these little miniatures, and it's really fast too.
Ooh.
And so you could get those are like $250, I think. So you could get 8 of them for $2,000, and you've got 8 machines plowing away at everything you throw at it, as long as it's a mini, and they'll output great quality, and you'll just have a pile of stuff ready for you to paint.
Wow.
Something like that. Yeah.
Okay, that's pretty cool.
Does that help?
It helps me. But no, I think that does touch on it well enough. Daryl Watts on YouTube asks, "Hey Joel, have you been using your Creality CR6 SE since you first reviewed it 3 or 4 months ago?"
Oh, hey Daryl. I haven't as much. So I did find that it's a good machine when I reviewed it, and unfortunately, there was a number of hiccups from Creality when the shipping units came out, and it led to the further thoughts that companies shouldn't get into Kickstarters, or we shouldn't review Kickstarter machines. It was just it was crazy.
Okay.
But the machine that I initially reviewed, the production sample, if you will, still performs well. I don't use it as much. Like it's at the studio, but if I load some filament and throw a model at it, it'll print it, and it'll do a really good job. I haven't been running it 24/7, but that still works well. The other one, so from the Kickstarter, one of the things I said was, I'm going to put my money where my mouth is, and I'm going to buy 2 of these from the Kickstarter because I reviewed it well, and I wanted to show people that I'm not just telling them to do something. I'm putting my money where my mouth is, and so I bought 2. And one of them, I went to plug in the USB port, and it sparked, and it killed the board, which that's not good.
No.
And the other one that I bought, I ended up selling to a friend for what I paid for it, and it's been running fine. So,
good. Okay.
So 2 for 3, 1 for 2. I don't know.
Sure. Well, and I see what you mean too about it sounds like you'd reviewed like a pre-production sample, like you said, and so that can be rough once it finally hits, mass production. Weird little things
it's really tough, because if I'm going to give you an opinion on something, but that something is nothing you will ever see, then what does it matter what I think of it? And so it's like, well, I have to say, here's something cool that's coming out. You have to remember, if you're going to invest in Kickstarter, you can also set your money on fire and get the same result. So you have to be careful and choosy and not use money that would otherwise feed your family.
Right.
And it's it's one of those things,
So Darth Asper asks, he's asking about when is the F1 project coming back? And so this one, I think, is a few years back. You took what was a very small model and swelled it up, right?
Just a bit. So the original OpenRC F1 project, I scaled it up 4x on all dimensions. So it used roughly 50 pounds of filament to print it. And then I had our friend Robert Canine. He did, thanks to Adam as well, did the power plant and the speed controller and the remote and the servo for the wheels. I've since then I've had my friends at Siemens machine out 2 stainless steel front axles for it.
Cool.
And then I used the really big printer in the garage to print a brand new front wing for it out of a different material. So it's slow and steady. It's just it's one of those things where it's really difficult because in the video that I did with it, the final one where it ran into the back of Adam's Tesla, we had the speed limit set to at maximum, it could use 10% of its total power. And the braking system wasn't figured out well.
Oh,
there were issues. Whatever, we tried. It was a lot of fun. So what I need is a very large, flat plot of land to run this on. Because if we can go 100% of power and I hit go, it's going to be a couple hundred feet away from me really quick. And on city streets, unless I'm running FPV, that's a problem. Even if I'm running FPV, that's a problem.
Oh man. Wow, that's going to be exciting.
It rains a lot here too, and it's not really suited for the rain, and so it's baby steps. But I
wonder if you could take it to it's not
Alameda
Pacific Raceways.
Those
Covington. Would they let you do that?
Go right?
Yeah, I mean, I think it's a loop, but that'd be kind of fun.
Oh, is it? It depends. So a lot of times when you go, it's I don't know. If it's smooth enough, it'd be worth a try.
Yeah,
I think it'd be really fun to be in a helicopter chasing it. But that takes a little bit of investment.
Sure. Well, yeah. Here we go. Armand. I'm not going to butcher your last name. So Armand on YouTube asks, question for Joel.
Forozania.
Thank you. What do you think will be the next paradigm shift in resin printing?
Oh, that's a really, really good question. Thanks for that, Armand. So resin printing, right now we're at a point where we've democratized it like crazy because machines and materials are as cheap as they've ever been for the highest quality they've ever been. And so I think what's going to happen is the next paradigm is going to be engineering different materials for people to be able to print. Because right now, like if the YouTube channel Integza, his name is Joel, legit good dude, but he did a ceramic resin where you print with the ceramic resin and then you fire it, which burns out the filler, and then you're left with a ceramic part to make a rocket nozzle. That's great. So now imagine more innovation around that, more innovation around being able to print something with a known shrinkage level that you could then fire and get a different material out of it, whether it be a steel or a different polymer or a wood, or I don't know. But I mean, I think what we're going to see is really cool innovations in materials. Because if we're talking about a paradigm shift, having resin-based 3D printers get larger or print better detail, that's not really a paradigm shift. That's just the trajectory, right?
Yeah, incremental improvement, I suppose.
Right. But a paradigm shift talks about a different use or the ability to grow into a market that wasn't once considered. And I think that has to be materials.
Sure. And you touched on an interesting point there. That's something that blows my mind every once in a while when I kind of run into this topic is the different materials that people are printing with. Like it was at first like copper and things like that. Like, oh, that's pretty cool. But now, but like you said, like it starts getting into a lot of other things. And just before the stream, you were talking about kind of this was more CNC related, but organic shapes and things. And then it ties into like construction. You see those videos of them like basically 3D printing concrete buildings. Yeah. And so why not? You could have these crazy twisted steel buildings almost if you could get it to print proper.
Well, think about it. Think about this. If you had a method, which is additive manufacturing, able to create structures that couldn't be machined or manufactured via any other method, and you could make it stronger than these other methods using same materials, or if you had these new materials that were even stronger, we're talking about using less material to make stronger parts. Yeah. And once that gets certified for different parts, like airlines, I know it's still crazy to talk about airlines using additive parts like additive built parts rather than machined, but we'll get there eventually.
Yeah.
And we're going to talk about lighter airplanes using less material that can fly faster and further with less fuel.
Right. I get the feeling we'll see a lot more inspiration from biology. Like you mentioned, airplanes. If we could 3D print the structure of an airplane in a similar way to like bird bones are very hollow and full of spaces, but they're still very strong to hold the bird together. I don't see why we couldn't do something like that for airplanes.
Well, we borrow from certain CAD packages. You can do load testing and strength testing. You can define your points and say, you know, how much stress can a wing made of a certain material, like you put in the numbers for the material, and how much stress can it be. Or you can say, hey, I need it strong here and it's going to be held together here. Create me a shape that will handle that stress the best. And then all of a sudden you have a machined shape that can't be made any other way than additive, and it's powering your design. That's just cool.
It is very exciting stuff.
That's just really cool.
I think there's a lot of application that is only just starting to be touched on. That's going to be very exciting. We have another question from YouTube. JL3D Printing says, hi, Joel. Do you know anyone that has got the MMU2S working on Marlin?
Oh, on Marlin. Okay.
I'm currently working on getting MMU2S working on my CR10S style custom build with an SKR 1.4 turbo and Marlin. So there was a lot of words that
There's a lot of words there. So essentially what he's talking about the MMU2S. It is a multi-material system for Prusa machines.
Okay.
And but Prusa is open source, and it's a motor and a selector, and it takes filaments. So you should be able to throw it commands to work on other machines as well. Okay. I haven't really been following that. I haven't played with the MMU2 or 2S yet. I've never got that in. And I really haven't followed any efforts in trying to get that working on other machines. So I have to apologize. I don't know. I haven't heard anything.
Oh, sorry. Right. So, so you say multi-material. So that's like, and I'm going to be just grabbing a few terms that I've recognized, but that'd be like PLA and PET. The basically different kinds of plastic or what have you that can go through the printer. Kind of like one of those old pens from the 90s when you'd slide the tab.
It's exactly like that. It's exactly like that. Imagine that, but imagine filaments. So if you have 4 filaments or 5 filaments going into different holes, then it knows what's in each hole and it can select, I want this one, load it into the system, do some stuff, and then it can retract it and then pick the next one and then put it down and do some stuff. Just like one of those pens, man.
That's cool.
You click that into color, and then you have to unclick the color before you click the next color, and that's exactly how it works. Like exactly.
Hey, that's cool. All right. Daryl asks, I was going to ask where you can get that STL file of the little mini Joel that your friend made up for you that one day.
Oh, hey, Daryl. So the original mini Joel, let's see, it is that one.
It's so cute.
Focus. There we go. There we go. That one. This was made by my friend Wexter, and it's over on My Mini Factory.
There you go.
Yeah, you can get that. It's just look for mini Joel or little Joel or I don't know, something.
I have a miniature Houston of my own, but it's
wait. You know what?
At the office.
For my friend that my friend made. So go back to Daryl's comment.
Oh, sure.
Can you highlight that one more time? But the little mini Joel that your friend made up for you that one day. So he could also be talking about
because there's the robot Joel, right?
Well, there's the robot, yeah. There's the robot, but there's also the Joel the Geomancer that Broken Anvil Miniatures made.
I've heard of this. Yeah.
And that's with their Kickstarter. I know they'll have their STLs for sale after the fact, but right now that's not available.
Okay.
Yeah. Jazza actually got that one and is going to paint it.
Oh, cool. That'll be exciting. That actually, so you mentioned that this company is going to sell the STLs. How do you keep that sort of thing proprietary? Like it feels like to me like a fundamental aspect of 3D printing is the openness of it. Like,
sure,
you could take something that somebody created and copy it and start making your own thing. How do you protect your custom thing in the
honestly
world? Yeah,
you don't release it.
Oh,
that's the only way, because it's so much. I mean, if I have STLs to sell, once someone else has possession of that digital asset, then it's honestly out of my control. I can associate different licenses with it. Like you can share it, but you can't sell it, or you can share it, but you can't modify it, that licensing. But at the same time, it's like once a digital asset has left my hands and is in possession by someone else, it is 100% out of my control, and you have to rely on the kindness of strangers, which I mean, I don't know. It's like rolling the dice.
Sure. And I do think the vast, despite the prevalence of digital piracy and things, I do think most people tend to be in the camp of like, I paid for this and yeah.
Most, yeah. But you run into, for example, a lot of people that do custom digital models that they then sell through their Patreon. Like they'll do 4 a month or whatever. Sometimes groups on Facebook will pop up where it's just free paid STLs, and people join up and they just post all of the STLs they've ever downloaded from a person so others can download them for free.
Yeah.
And then we have to complain to Facebook and they have to shut it down. And thank goodness that it is a lot more kindness out there than there is terribleness.
So I mentioned I have a little miniature of myself. We used photogrammetry to make the 3D model of that. How often do you, if at all, do you use any sort of photogrammetry software?
I don't. I don't at all. It's always interesting, and I know how to do it, but it's taking a lot of photos and it's putting it together, and then it's printing something. And if there was something specific that I wanted to recreate digitally, that's probably the method I would go with. But I don't know. There's imagine 3D printing as a tool or scanning as a tool. And I just haven't had the job that I want to use that tool for yet.
Sure. Oh, that makes sense. It was really fun. And it did seem, though, to add a few extra steps because, like you said, you have to take a bunch of pictures. You load it into the photogrammetry software to make the point cloud. The point cloud then becomes a 3D model. The 3D model then has to be sliced. The slices have to be fed to the printer. It seems a little complicated.
Just involved. Just a little bit. It's just a little bit, but it's enough to where it's just not something that I'm playing with at the moment. Yeah.
Okay. Adrian Girardot, I think this is going to be the French pronunciation.
Girardot.
Do you think that home 3D printing might help develop flexible mechanics applications and industrial concepts for everyday use? Things like flexible joints, for example. To me, TPU feels magical.
Oh, absolutely. That's part of what's awesome, because 3D printing itself has been democratized right now to the point of getting as many people as possible into the hobby. They're experimenting with rigid materials and flexible materials and putting them together and using and making inline joints. That is going to, I think what you're going to find is that a lot of the younger generation right now, I mean, not necessarily right now, because everybody's home, even though they don't want to be, but stepping back a little bit, the younger generation right now has access to a lot of really incredible tools and the ability to collaborate with others. And so I think what we're going to have over the next 5 years is an incredible amount of highly qualified individuals ready to work on the next generation technology because they've been playing with it in their garage. And I think that's the most exciting part. We're going to have people ready to design right out of school, already using the stuff that the business is trying to use. We're going to have qualified candidates just ready to go. Just boom, boom, boom. It's going to be a lot of fun.
That'll be really good. I especially like seeing the medical applications. I've seen like 3D printed casts that have like this kind of webbing look to them, and so it's like more airflow, but it's still rigid enough so you can keep your arm together. Like prosthetics, which I love to see when homebrew stuff does better than like the professional or like commercial solutions. It tickles me quite a lot.
Well, that's just how it works, right? Because homebrew is able to pivot and create a lot faster. right? When you look at industrial solutions, you look at machines that are old and archaic, running older machines with people who had to learn stuff in college, and they've just been doing it for 20 years, so that's how they do it. It's like when the big need for PPE first came about, when everybody needed these face shields and masks, that's why you had people in the maker community be like, "Oh, I know how to make this," and so they used what they knew, and we made lightweight, easy to reproduce headbands that could then take a binder or an overhead sheet as a clear plastic visor. And I know it wasn't perfect, but at that time, it was able to ramp up within hours of the need, and we got something awesome, while traditional manufacturing could then play some catch up and get going. And so it's always going to be or I guess it should always be, that homebrew can pivot and create faster, but then lessons learned from that should be incorporated into the trajectory of more traditional processes.
I agree. Yeah.
In fact, our buddy Ren over at Corridor Digital, did you see the episode where he did the little prosthetic for his buddy that was missing part of his finger? And he used 3D printing and twine, and they had to fit it, and it, different sizes, and then so cool. So it was great.
Yeah, I'm curious. So it seems like 3D printing is almost like sort of hobbyist. What are some of the big commercial applications? Like what everyday thing does someone maybe interact with that they wouldn't realize is 3D printed or adjacent?
So you're going to say it's going to be parts within typical manufacturing. So there's not that much out there right yet that's just easily relatable.
Okay.
As an example, Siemens in Germany is using additive manufacturing to make parts for their industrial steam turbines, which can service a couple 100,000 homes with power. I can say that, and you and everyone else can be like, "That's cool, that's cool." But I can't point to something in your kitchen and be like, just like that. And so it's really, really hard to relate it. We're getting more to a point where people know more about the technology. It's just still really, really hard to throw out something super relatable, because your mechanic down the road isn't just printing parts for cars that they're using, to fix old cars. It's being done, but it's just not a common practice. There are parts that airline industries are 3D printing that go into airplanes. No, it's not the wings that flap or nothing, but it's right. It's stationary parts and brackets and wire harnesses and stuff like that. So, I mean, there's advancements in the bio industry because they're able to 3D print organs and stuff. They're not always doing it. It's not like it's just a section in the hospital where they beep, beep, beep like a microwave and out spits a heart. But, but we're at the beginnings of where 20, 30 years down the line, that could be the typical normal. And so we need the young kids that I talked about that are growing up with just knowing this, getting into the workforce, and we'll see that explosion of innovation in 5 to 10 years. That's my guess. That's my guess. It's like, it's just like if you give a small child an iPhone or an Android or whatever, and they are able to unlock it, just because it's such a native move, right? It was brilliant, that little slide to unlock. And you can give it to a small kid who's never seen it before, and they will be like, "Oh," and they'll unlock it. It's a very, it's a mechanical experience, and your brain just gets it. And so with all those kids that are growing up right now, they're going to know about the processes. They're going to know the slide to unlocks for manufacturing. And it's just, that's why I think we have a really bright future ahead of us.
Yeah, it's very cool. And again, like it's touching in industries and places where we wouldn't just automatically think about it, because there seems to be that sort of gap between, I've got this little cute little test robot thing that gets printed out versus you're saying wiring harnesses or weird little flappy parts on things. And
well, here, go to the Imagination 2 forum comment. It's wasn't Gillette using 3D printing for their handles too?
Oh, sure.
So that I went to Gillette. We talked about it, and it was an effort to kind of do this, just to make these custom handles for shavers. And it wasn't like the whole company's doing it. It was more like a group within a group, that was really nimble, being able to do this. In fact, they made me. I've never shown this before, I don't think, but they made me a custom one.
Oh, that's cool.
So it's my Joel bot with a razor handle on it.
Whoa.
Yeah.
That's cool.
Yeah.
That's really
But
neat.
that's where, that's interesting, right? It's not a product per se, but you can now take something traditionally known and make something custom. So you don't need a JoelBot handle, but what if the handle had finger holes in it for those that couldn't hold the razor? Or what if it was sloped in a certain way for someone who is missing a partial finger to be able to hold it better? And so that's when we start talking about it being awesome, but it's still bespoke, it's still custom. And so it's not a push to having a major manufacturing effort move to it, but it's able to let people use something that wouldn't have been able to use it before.
Right. That's pretty cool. Yeah, that's awesome. Let's see. It just, I'm endlessly fascinated when I do this, talking to different people and broadening my own understanding of how these tools are used, and it's always so cool because like there's comment from JL3D Printing, Ferrari 3D prints pistons, like that's pretty cool. Like, so
not all of their pistons, and I'm sure they're just testing it,
right? But that's kind of mind blowing because like
it is.
You're printing titanium, or like what do you 3D? Because it's not just plastic, like that. I think is the common conception.
Well, imagine. Because I showed this off in Görlitz, Germany, when I visited Siemens. And imagine a head. It's a CNC head, or like a MIG welder. It's just a MIG welder just spitting out metal in a shape, and then they can mill it to smooth it. And that's how they made the axles for my car. Yeah, but it's possible to make that. And the idea is it's using cheaper stock to get, and it's not wasting as much material. So it's kind of interesting.
Yeah. Oh, let's see. Did I miss anything?
I don't know.
Just a lot of talk of car companies using 3D printing for production parts.
Oh yeah, there are tons and tons of companies using additive manufacturing to make all sorts of really cool stuff. It's just it's not their main effort.
Sure,
it's prototyping and stuff like that, which is awesome. It's just really hard to convey that to the typical household.
Sure. I'm curious some of your thoughts on, and this is going to kind of touch back on the piracy topic, but I guess there's that old ad, you wouldn't download a car, right? Well, we're at a point now where you kind of could.
Oh, sure.
In a real way. Like I do remember there being an article of somebody who 3D printed themselves like a Porsche, or at least the body of
no, it was a Lamborghini. It's a 3D printed car. It's a Lamborghini Aventador. I don't know, something like that. Good people. Okay. I'm gonna go visit them. They're in Colorado.
Oh, nice.
Yeah, they've on their CR10. They're just printing the parts for it and they're making it. I mean, obviously, it's still gonna have a powertrain and brakes and wheels and instrument cluster. I mean, it's going to have all the regular car stuff. It's just the frame itself is the plastic with some fiberglass resin kind of enforcing it, and then that becomes the body.
Okay, so I'm curious, what are your thoughts on? I guess that's sort of where is there a line to draw and is this nefarious? Because they're kind of stealing a design for themselves. Is that weird? Is that bad?
That's a very interesting question. So Lamborghini's okay with it.
Oh, cool. Okay.
Like super okay. Like they actually invited them out to track day. They gave them a real car to drive around for a week just to show it off. Like it's amazing because it's something that not everybody's going to be able to like your upper crust multimillionaires who want to buy Ferraris. They're not going to opt to get a 3D printed one from someone's garage.
Sure.
So if you look at it from a business standpoint, Lamborghini isn't losing any money, and they're getting free publicity, right?
Sure.
A company that makes vehicles for very select individuals all of a sudden is involved in a heartwarming story. So I mean, it would be in their best interest to just push it like crazy. Now, if a metal 3D printing plant like Siemens was able to 3D print all the metal parts for a Lamborghini and source the fiberglass shell for a Lamborghini and sell it as a Lamborghini but cheaper, then we'd be talking about a business issue.
Okay. Well, I suppose it just occurred to me while I was thinking about it that it kind of bumps into a similar area as like kit cars. You know, you can buy a Volkswagen and turn it into a Ferrari with a shell and things like that. And I guess that's kind of occupies that weird sort of gray space. I'm not sure the
sort
rules
of
on that.
Think of it more along this way. Years ago, before I had a YouTube channel, I was 3D printing cookie cutters and selling them. I thought, I have a 3D printer. I'm going to make money. I made Seattle Seahawks cookie cutters and I sold them. So technically, I was legally in the wrong because I was using a trademark logo in a way that I wasn't expressly provided to me and selling it. I was making money from it. I didn't get in trouble, but the Seahawks, their front office did say that we know we have a lot of fans who are very creative and selling stuff on Etsy, and we typically will not go after them because we just want all of our fans to have all the stuff. But I guarantee you, if the Seattle Seahawks were selling cookie cutters, they would shut me down in a heartbeat.
Sure.
Because then I would be interfering with their ability to make revenue on a product they sell.
Got it.
Yeah.
Okay. And okay, that makes sense. I feel like that's a good kind of the line.
I hope that makes sense, right?
Yeah.
It's like one of those things. I mean, don't be a jerk. And if you do something that's probably nefarious and wrong in nature, you'll probably get caught.
Right. So, all right, we have some more questions from YouTube. Ben E. Brady asks, Joel, of all the printers you've used, which I imagine is quite a lot, which is your absolute favorite?
Hey, Ben. So the problem with that question is it assumes that I am going to stack rank everything, and I just don't have the mind space for that. So typically when someone asks this question, I will say it's the one near me, powered on with the filament I need, ready to go.
Sure.
And I say that because it depends on the situation. If like behind me is the Daedalus from Project R3D, and it's loaded with some atomic PLA, and it's ready to go. When I power it on, I just upload a G-code file and I hit print. It's calibrated. It is good to go, right? And so right now, it's probably one of my favorite machines to use just because it's set and ready to go. When that wasn't there and I had a Prusa Mini back there, that was probably one of my favorite machines because it was right there, ready to go, typically loaded with the filament that I need. And so it's more situational. It depends on what I want to print and what material I want to print with and whether or not that machine is ready to go. Like it could be that I have a machine in my studio loaded and ready to go with exactly what I need. But I would think, wow, that's going to be my favorite printer now. And I'm going to take the trip over there and I'm going to set it up and I'm going to be really excited. And I'm going to use it. And then I come home and there's something else I want to print. Then I'm like, oh, you know what? I'm going to hit this one behind me. And I'm like getting it going and it's just laying down perfect. And I take a picture of it and I'm like, this is awesome. So it's very situational. It's just,
sure.
It's almost like, they're all my favorites, depending on what they're doing, right?
Yeah, and that makes sense, especially in a creative space, because like, some people ask like, "Oh, what's your favorite like paint to use or whatever?" And it does. I feel like in creative pursuits, it really does depend. It's situational. Like, what are you trying to accomplish? And
hey, Houston, what's your favorite video card CPU combo?
Mine, right? The one that I have.
It really depends on what you're going to use it for, right?
Right. Yeah. Oh, yeah, absolutely. Because it makes a big difference between 3D rendering or Photoshop or video games and all that sort of thing. So yeah, it depends on your goal.
Exactly.
Let's see here. Oh, I have a question. I'm maybe you've already touched on this in your own content. It's really hard for me to keep up with everybody. I've seen some videos of yours that you're printing something on a bias. Usually it's like at a slant,
on a tilt. Yeah.
So, what's that about? That's kind of new and different.
It's sort of new. So it's been around for a few years. The idea being if you were to print onto a moving platform, then if the nozzle's like this and the bed's like this and it can print, then the platform can move and eject the part, and then it's free to print again. So it's it's a mass manufacturing method. However, if the nozzle was tilted like this, then your plane is like this. And so you print a little here, you print, and then you print, and then you print, and you print, and you can print forever.
Right.
Like, is this going to work? There we go.
Oh, yeah. There it is.
So, yeah, this piece, right?
What is that?
This is going to be for a camera arm.
A camera arm?
Or a light arm, yeah. So I'll be able to, it has threads here that I can screw down. And then when I print another one of these, right, this hole will interface right here. And then I can have it adjustable and yeah.
And so is there a reason it's that big, or is that just for the lulls?
I scaled it up to be 700% of normal size. Normally it's, the Pixar lamp. Normally it's like that scale. It's just a little desk accessory. So it's just like that.
Yeah, like a boom
it's just like
arm.
that, just like your mic boom. But this one, I was like, I have a belt printer. Let's see what happens. So Caleb over at Make, he had the review of the belt printer from Creality, and he printed it at 200% scale. He showed it off. I was like, that's cool. And I have an idea. And so it became my favorite printer at the moment. See what I did? And I was able to print that out. And I just kept taking pictures on Twitter, and I'm like, it's going. And sure enough, it worked.
I love it.
Yeah.
So it is just that big not because like the light is that heavy or anything. It's just because it's funny.
Because I could.
Yeah. Oh, that's so cool. I love it. It's really cool. Here's an older question, and this one might be a little bit of a vague and depending one. What is the best cheap 3D printer?
Oh, well, the word cheap sometimes means not of good quality. And so I'm sure they don't mean that. I think what they mean is what is the best, least expensive machine, right?
Yes, I agree.
And so right now, your options are going to be really, the Ender 3 from Creality and its flavors. They've gotten the quality down on that, and I think they're great. The Ender 3 V2, probably the best version of that one, and it's, I think, $269 US, I think. But it goes together really easy and prints right from the get-go. Looks superb. Awesome. On the resin side, I know I talked about it, the Frozen Sonic Mini 4K. It's going to be, I think it's going to be $250, but because it's so small, it has a 4K screen, we're talking about tiny pixels to be able to cure that resin, so you get amazing detail. And honestly, if you have $400 US, you can get either resin or filament, plastic extrusion and material, and have money left over.
Wow, that's not
bad for a high-tech hobby, right?
Yeah, that is. Could I
get a $400 PC monitor keyboard combo? That is worth anything?
Yeah, you could, but what are you going to do with it?
It's a Chromebook.
Yeah, right. That's pretty cool. So we got maybe about 10 or 12 minutes left. So I'm gonna.
Oh my god, we haven't even talked about workflow.
I know. Oh, well, a little. Because actually I did ask that kind of near the beginning, but we got a little distracted.
Tangents, man.
So I guess describe how it works for you then. Like, again, from like idea to thing.
Well, so filming. So Sean is in Michigan. He's my editor, and my producer David is in Los Angeles. And so what I will do, we'll talk about ideas of stuff to film, and then I'm here. So I will film it, and whether it's my C70 on sticks or I use a Canon R5 or a Canon XF400 or a Blackmagic Pocket Cinema 6K or a GoPro or an Osmo or my iPhone or whatever, right? I will figure out the best way to film, hopefully in multiple angles, whatever I'm doing. And then what I do is I take all that footage off onto my PC and I just verify it looks good. I'll run it in VLC or bring it into Resolve just to verify it looks good, scrub the audio. Then I drop it in a Google Drive.
Okay.
And that syncs up there, and my editor Sean in Michigan will pick it up, and then he will edit it together for story and put out an RC cut, and then he and David and myself all watch it. We make notes, time code notes, whether we need to squish stuff or expand stuff or add stuff or remove stuff or whatever, right? So then Sean will do the edits, and then we will get back an FC or a fine cut, and we watch it, and if that's good, then that's what gets scheduled for YouTube to release whenever. Okay. He syncs all of his assets to Google Drive. I then bring them down to my home machine, and then I use those assets to create thumbnail candidates, which I then text out to Sean and David, and we talk about which ones we like, which ones we don't like, and then we pick one that gets associated with the video, and then it's scheduled for a time and a date of release, along with metadata, keywords and links in the description, all that sort of stuff.
Sure.
Once that gets scheduled, then I take my folder full of all that stuff on my PC and I back it up to my server, and I'm running Unraid on a 24 disk system, and that holds everything. And then it gets released, and then that's it. That's in a nutshell. That's the workflow. Sean's going to be moving back here, so then the workflow will be modified a little bit. So we'll have more handheld camera movement during certain things, or he'll be able to set up stuff while I'm setting up other stuff, and so our workflow will be condensed a bit because more than one person is doing it. Yeah, that's kind of what we do, man. That's
pretty cool.
Day in, day out.
I didn't realize it was so remote, and that's kind of an interesting peek into that as well. How about that? That's really cool. Wow. So when it comes to like reviewing, and this is going to be because I haven't consumed a lot of your content, I apologize. Do you have like a standard set of prints that you do to test and review? Or
for review, yes. For review scenario, I do have a standard 4 or 5 prints that I run just because I know how they should look. Like I know how they should exactly look, and any printer worth its salt should be able to print these no problem. Okay. But then we move on to just flavors. Hey, what's current? What looks good? What's an idea? Hey, my friends made these models. Let's see how these look. And so filming those, I'll either get motions with my iPhone, or I'll set up a GoPro or the Osmo to do a time lapse.
Oh, okay. That's cool. Time lapses are always fun.
They're always fun, yeah.
So I missed a question. Adrian asks again. He says, French guy at it again. I've been using my FDM 3D printer for a few months now, using only SD card. Do I need Octoprint and a Raspberry Pi? What are the most gains I could make using those? Oh,
that's a good question, Adrian. So you don't need it. Running a Raspberry Pi and Octoprint on a machine basically enables you to do more stuff with it. So if you feel deficient in what you've been able to do with your machine, you don't need it. But if you have a Raspberry Pi laying around, Octoprint is free to install and use. So then you get remote control of your machine on your network. You can also hook up a really cheap USB webcam to be able to watch over your print, or to be able to film a time lapse every time you print. With Octoprint, there are plugins. One of my favorites is Octolapse, which allows you to make one of those time lapses where the head stays in one spot and just moves up, and it takes a picture every time. Yeah. So I imagine, so you don't need it, and I don't have Octoprint or a Raspberry Pi on all of my machines, but it allows for easy remote control. And if you have multiple machines and you had multiple Raspberry Pis, then you could via my buddy Tim over at TH3 does this. He's got Raspberry Pis on all of his machines, and he has a power over Ethernet switch that he runs Ethernet to each of these, so that the Octoprint gets an IP address, but then the power over the Ethernet also powers the USB port on the Octoprint. And so what's great is if for some reason he ever needs to reboot the Octoprint, he just power cycles that port on the switch and then it automatically does it. But then he's running remote on the machines and he can monitor them from one location. And then if something's wrong, he can pause them from remote and go fix it. It's always interesting. And if you just happen to have a Raspberry Pi laying around and it's not doing anything, it's not a bad use for it at all.
Right on. That's pretty cool. All right. Daryl asks, Joel, could you do a show on how to calibrate the Creality CR6 SE? He says, mine works good, but I'd like to make it run optimum.
Oh, well, so Daryl, the issue with that is I haven't run into any calibration issues. So with the CR6 SE that I've been using, I used Creality Slicer, which is just Cura 421 with a different skin on it. And it just worked. It worked. I haven't had to calibrate it at all.
Awesome.
At all. It just worked. And so I don't really have any tips or tricks for calibrating that machine other than, the normal stuff, like just making sure it's lubricated and making sure things are tight that should be tight. You can always adjust your filament extrusion multiplier, just if you're spitting out too much or too little filament. But one of the things that you said, mine work good, but I'd like to make it run optimum. And so tinkering with your machines is always a really fun time, but I mean, and just like Houston, just like with computers, tinkering with voltages and trying to get the most out of it, right? So if you're a tinkerer, that's great. I don't really have any guidance for you, but there are a lot of people out there who will talk about stepper motor voltages or certain material profiles or something like that. But you just said it's working good. And so if you run across a print where something isn't working as good as it should, then you have a mission at hand because you have a goal of fixing this thing.
Sure.
I mean, general tinkering is fine, and throwing new bits into like PCs is fine. Houston will tell you that. But at the same time, if it's running well and there aren't any issues, you just want it to run peak. You're starting to get into that territory of like it's more of a personal thing. There's no way to really tell you how to run it better if it's already running well. If it runs across a certain issue, like if it's not cooling fast enough, or perhaps your bottom layer isn't as good, or your top layers are messed up or something like that, then we can start to diagnose. But if it's already running good, just print everything until you run into an issue, and then we'll help.
Okay, sure. Yeah, it's like, don't fix it if it ain't broke, right?
Yeah, I mean,
because you start.
Good luck, right? I mean,
yeah. Oh, I mean, because sometimes tinkering introduces more problems than the benefit.
Sure does.
Out of it. I would point to the overclocking scene for that as an example. You can do some serious damage by tinkering too much.
Yeah.
There was a bit of talk going on about different materials, SLA being messy. So would I go with FDM? Could you give a little insight into that, like the different materials and different applications for them? Because I know there's
like between resin and FDM.
That or I know there's different kinds of filament as well, right? There's
different kinds of filament. They're all going to be plastic based because they all have to melt and be extruded through a nozzle, right? I mean, toothpaste comes in all different flavors, but it all has to be toothpaste that you can squeeze out of a tube, right?
Sure.
So, but with resin is a bit messy. There's more post processing that has to be done, but you get more detail out of it. And so, I think though, if you can, and you're interested in both, we're at a point where FDM, fluid deposition modeling, right? Melting plastic, and resin-based 3D printing are so inexpensive for decent machines that you could get one of each and dedicate a space into your garage or your maker space or wherever you do your hobbies. And just know that there are certain things you have to do with this one, and there are certain things you have to do with this other one. This is a little bit more messy, but it's more detail. This isn't as messy, and it doesn't get you quite as much detail, but there are more color options.
Okay, sure. Is there anything to consider beyond, or I suppose from like an entry level standpoint? I know at least early on there was a lot of fiddling you had to do with a 3D printer to make it work well. Like I know early on, like the Ultimaker, there was all kinds of weird stuff you had to tweak and edit. Is there still that sort of thing on the additive manufacturing side? But then also, is there anything to consider for a beginner in the resin space? Like, how hard is it to?
Oh, I see. Beginner in resin is really interesting because beginner in resin just means typically smaller, right?
Okay.
It is usually an LCD here that then blocks the light going up and curing a resin, and you might have just a little tiny build plate and it rises up and down, and usually smaller resin just means less expensive. On the FDM side of things, you can still get a box of parts and have to put them all together. In fact, there's a lot of DIY efforts out there to make doing that more fun. There's something called the Voron, and I want to build one of these machines, but you have to print your parts, you get extrusion, you get wires, you run everything, you put it all together. But it's supposed to perform really well. And that's part of what makes that fun is the community behind it. Like if you just get a bunch of parts to build a machine and you want to get involved in a community doing it and there isn't one, it's not as much fun. But like with the Voron, if everybody looks up and builds Vorons, I think we'd have a much more well-educated society because it's a fantastic thing.
Right on. Is the resin, is it toxic at all? Like, is it weird? Do I got to wear rubber gloves and
you don't want to drink it. Right. It is just imagine an epoxy resin at Home Depot.
Okay.
Are you going to drink? You're not going to drink that. Are you going to wear gloves while you handle it? Yeah. Are you going to wear a respirator or be in a ventilated area? Yeah. It's probably for the best, right? Because it's going to off-gas some things. With photopolymers, the stuff that cure with light, you're still talking about very similar things. I mean, here's the thing. If you accidentally spill a little bit on your skin and you clean it off and wipe it off, no harm, no foul, most likely. It's really, I mean, if you have a personal sensitivity to the ingredients within these, then you might get a reaction. It's really up to the person. It's almost like an allergy situation.
Okay. And
then once you develop a sensitivity to ingredients within resins, that's lifelong, and then you can't be around them. So what I do, I wear gloves, and I wear a respirator, and I do my work with it. And I have done it without a respirator in the past, but sometimes the resins are really stinky, and I just don't want to breathe that.
Okay. Any special gloves? Are you talking like dish gloves?
Nitrile gloves. Those work.
Okay,
the kind you can go get at the hardware store, like for a box out. Yeah. It is toxic. A company should be able to give you an MSDS for it. You should be able to get a list of what's in it and at what proportion. And you can go through and be like, oh, yep, that's toxic. That's carcinogen. Okay, good. Yeah, it's it's messy, and it's with a substance that is a little toxic. So you should probably treat it with respect.
Sure. Yeah. All right. We touched on this earlier, but I'd like to come back around to this as well. If you were going to recommend a decent resin printer to buy as a first one, what would you suggest? And I think
we talked about that. And, hey, Miles, how's it going? That's my buddy Miles over in the UK.
Oh.
Yeah. So I think if you're looking at any of the less expensive Anycubic machines, the Elegoo Mars resin printers, the Frozen Sonic Mini 4K. All of those, like any resin-based machine that is sub $400 or $500, really right now is fantastic because they're going to print well, and you're going to be able to experiment and join in a hobby without having to spend too much coin. I mean, there are larger versions of all of these, or more feature-rich versions of these, but really, I mean, just. Dude, go get a Frozen Sonic Mini 4K. Like it is, I was amazed at how easy it was to set up and the quality of the prints that came off of it.
Just in case, I've already got the link for you.
Look at that.
Because that sounds pretty
Bam!
cool. And I want to look a little bit more into that because that sounds really neat.
There's probably an Amazon link too. So.
Oh, I'm sure that's direct to the manufacturer.
Yeah.
All right. So we are a little bit over our hour. I'm curious. One more question. what are you most excited about looking forward?
I think looking forward, I think that I'm looking forward to society getting back to some form of normalcy. I think part of the joy in this hobby is being able to meet others in real life and talk about the ups and the downs and inspire each other via that method. That's one of the things I'm really, really looking forward to getting back to. But I think in this year, it's going to take a while till we get back to doing that. And so I'm just excited to be able to, from my home or my studio, be able to show off new, cool tech that may not be easily accessible by others. Like I have a giant $38,000 3D printer in my garage. I know not everybody's going to be able to do that, but it's really exciting for me to be able to show my audience the ups and downs, the positives and the negatives to having a giant industrial 3D printer in your garage. And so I'm reaching out to other manufacturers and companies. And I think being able to, instead of travel to these places, like when I traveled to Siemens in Görlitz, Germany, I can't do that right now. But if there's a way for me to trial industrial tech, but local to me, and I can show it off, I think there's going to be some fun there too.
How big is giant?
1 meter by 1 meter by 0.7 meter is the build volume.
Oh, wow. That is pretty big.
So I could print multiple computer cases at once.
Yeah. Hey.
Or I could print a giant computer case.
Right on. That is really cool. Okay. And so I guess we'll call it at an end there. Is there anything you'd like to mention or shout out or say to the audience and anybody in the future who's watching or listening?
Yeah. So everybody next to me here, this is Houston. He is a rad dude, and he's not just a beard connoisseur. He is actually a kind human, and he's the one that built my machine. The one that I'm streaming from right now is a Core i7 system built by Houston at Puget Systems. They are a wonderful company run by some really amazing people that make really good stuff, and I hope you check them out.
You're gonna make me blush. You can't see it, but it's there. Well, thank you, Joel. That's great. And as well, I'm gonna tag onto that. And if you don't already follow Joel on YouTube and on Twitter and Instagram, do that. You're the 3D printing nerd everywhere, or
I think if you just look up 3D printing nerd, I show up.
Okay.
Yeah. Or I'm at Joel Telling on all the socials.
All right. Awesome. Well, thank you so much, Joel, for joining us today and taking time out of the day. This was so much fun. I'm sure we could go on and on about this.
We'll have to do it again.
For sure. Thank you so much. And thank you as well to the audience for joining us on our Workflow Wednesday. We do this every Wednesday and Friday at 1 p.m. Pacific. Wednesdays, we bring in industry experts like Joel here to talk about their process, workflow, and tips and tricks. And then on Fridays, we have a member of our labs team join us to help answer questions from the audience about the crossover between hardware and software. And soon, we'll be expanding that content beyond just the labs team to involve our support staff and consulting as well to kind of get a little bit more insight into how we do things at Puget Systems. So that's going to be really cool. And so mark your calendars, you guys, for that. That's Wednesdays, Fridays, 1 p.m. Pacific. And we'll see y'all next time.
Sweet. Bye, everyone.
Bye.